All right, this is day 4 for Unit 6.1 classwork. I'm going to pick up where we left off yesterday, where we are writing the inverse of the function that I provide. So remember, we make this y equals x squared minus 9. And this is just a restriction that we're setting that x has to be greater than or equal to 0. Remember, in this case, just a restriction that is put on here. So let's first do this. Switch your x's and your y's. So we have x equals y squared minus 9. Now, we're solving for y, so we're going to add 9 to both sides, and we get x plus 9 equals y squared. Now, we're solving for y. So the opposite of y squared is a square root. And if we do a square root on this side, we have to do a square root on that side. Okay? Now a square and a square root cancel out. So we are left with y equals the square root of x plus 9. Now, coming back to restrictions, this works. Okay, well, let me go ahead and rewrite it. Negative 1 of x equals the square root of x plus 9. Now, this works as long as underneath the radical never is a negative number. Because remember, in square roots, you can't have negatives. It's imaginary. So we have to put on the restriction here. Okay, put on this restriction that x has to be greater than or equal to negative 9. Negative 9 plus 9 is 0. We can have the square root of 0, but we can't have the square root of negative 1. So it can be negative 9, it can be negative 8, negative 7, and continually increasing. So we just have to put that restriction on here, or we call this the domain. Okay, it's like a domain restriction. Okay. All right, number 11, very similar. Number 11, we're going to write y equals x plus 4. And I think I might have done this one in class, but I'm just going to go ahead and put it on here. Switch your x's and your y's. So y plus 4, this is all one binomial, one term, cubed minus 6. So we're going to first add 6 to both sides. And we get x plus 6 equals y plus 4 to the third power. Now, ask yourself, remember we're solving for y. How do I get rid of a cube? Well, the opposite of cube is cube root. The little 3 goes in the little nook. Remember, all the roots go in that little nook. If we do it on this side, we have to do it on that side. Okay? All right, so now we have the cube root of x plus 6 equals a cube and a cube root cancel out, y plus 4. Again, we're solving for y, so we're going to subtract 4. Now, this minus 4 does not go with any of this stuff. Your answer is the cube root of x plus 6 minus 4 out to the side equals y. And the only thing left to do is to change that. So let me rewrite this. Cube is x plus 6 minus 4 equals f of negative 1 of x. Now, I do not have to set a restriction on this problem because cube roots can be positive and negative. So any number works in this case. All right, now let's move on to the new material. Okay, let me make this a little bit smaller. And we are going to move on. Okay. All right, two functions, f and g, are inverse function if and only if. Oh, good question. All right, this is the tricky part. Okay, so pay attention to this. We've talked about this a little bit, but not fully. So let me read the question again. Two functions, f and g, are inverse functions if and only if I'm going to write it out. If I'm going to put g of x inside f, and also the opposite, I'm going to put f of x inside g, and when I solve and do this, my answer is x for both. That is the only way you can tell me they are inverse functions. Okay? So watch how I do number 12. Let me make this, give me more room. All right, the first one I'm going to do is I'm going to put g inside of x. Now, we've practiced this already. We've practiced that we're going to write f, because it's on the outside, x squared plus 8. I am going to erase the x, and I'm going to put, let me choose a different color to do this. And I'm going to put square root of x minus 8 inside. So square root of x minus 8 inside. Okay? Now, we're going to solve this. Here's the fun part. Let me get my color back. Remember, we just did this. Square and square root cancel out. So we are left with x minus 8 plus 8. Oh, that's not an 8. Plus 8. All right, now negative 8 plus 8 is 0, so this is x. See how we did that? We put this inside of this. Now let's do the opposite. G, and we're going to put f of x inside. All right, so I'm going to write out g of x. Square root. Instead of x, I'm going to put x squared plus 8 minus 8. Okay? All right, now let's solve inside the radical. Plus 8 minus 8, that goes away. Here, I'll cross those out. That goes away. So we are left with the square root of x squared. Remember, square and square root are opposites. They cancel out, so this equals x. Now, as long as you do this and both have an x, you can say, yes, they are inverses. Okay, let's do another one. All right, let's try this one. Here we go. First one we're going to do is we're going to start with f, and we're going to put g. I'm going to do my parentheses, and we're going to write g inside. Okay, so here we go. Negative 4 x plus 5. I'm going to erase the x. Oops, we don't. And in place, I'm going to put all of this. X over 4 minus 5. Okay? Now, when you're looking at this to solve, you're going to distribute. So in essence, I'm going to spell it all out so you can see each piece. Okay? So negative 4 times x over 4 minus negative 4 times negative 5. That's the distributing, and then I'm going to add 5. So let's do this first one. The 4's cancel, but I'm left with a negative x. Now, a minus and a minus is a plus. So I'm going to make this become a plus. And then I'm going to say 4 times negative 5 is minus 20 plus 5. And then I'm going to combine these like terms, and this becomes negative x minus 20 plus 5 is minus 15. That is my answer. So far this isn't looking very good, because remember, it has to equal x. Let's do the other one just anyway. We're going to do g, and we're going to put f of x inside. So here we go. X over 4 minus 5. Okay, so I am going to erase the x, and I am going to put negative 4x plus 5 inside. Negative 4x plus 5. Well, I'm going to do that infamous v, because I have to make this work. So this is negative 4x over 4 plus 5 over 4 minus 5. I just broke this up because I know those cancel. So I have negative x plus, now 5/4 minus 5. So in my calculator, I'm going to go ahead and type in 5/4 minus 5, and I get negative 15/4. Negative 15/4. Well, we can definitely see here that's not x. So the answer is no. These are not inverses. Now, technically, I could have done the first one. Oops, I'm so sorry about that. I could have done the first one and stopped. But I wanted you to get some more practice in, if I can get there, and try the second one too. And of course, they both don't equal x, so they are not inverses. Okay? All right. We are going to move on and learn about graphing. Okay? We're going to learn about graphing. All right. So this is just kind of one to look at. We'll probably go through this one. I will stop and I will move on to part 2 of day 4. I'm going to plot these 3 points, okay? And I'm going to plot them in red. So -1, it's really small. So let me see if I can make this a little bigger. There we go. -1, 6. -1, 1, 2, 3, 4, 5, 6. Here's that point. -7, 1, 2, 3, 4, 5, 6, 7, and up 2. There's that one. And -5, 1, 2, 3, 4, 5, down 3, 1, 2, 3. Here's this one. And I'm going to connect these dots. And you can see we drew a triangle. Okay? Now, I just plotted it. Now, what is the inverse? So let's go ahead and put the inverse down. Here we go. 6, -1, 2, -7, and -3, -5. All right, I'm going to now plot those 3. All right, so we're going to go 6. 1, 2, 3, 4, 5, 6, down 1. Then 2, 1, 2, down 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go -3, 1, 2, 3, down 5. 1, 2, 3, 4, 5. And I'm going to connect these 3 dots. And if you notice, these are mirror images of each other across this line right here. And it's a line that if you were to plot it, the line is called y equals x. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. And it's a line that goes through all of those points. Okay, so we know they are mirror images. If I can write, whoa, this pen is being really weird. Mirror images across the line y equals x. Okay, it should be if they are truly inverses. All right, I'm going to go on to part 2 of day 4.